Alright, so we're going to start with a new chapter today, and that is exception handling. Now, if you recall the previous classes, in fact, the classes when we just started C++, I told you the difference between C and C++, right? So I told you that C++ is basically, object-oriented programming language. However, the entire C programming can also be done through it. That means you have the entire C. Along with the entire C, you also have some additional components which are available in C++. Now C++, other than giving an object-oriented programming capability, it also gives certain extensions which are not available in C. One of the extension is exception handling. Now in C++, you can handle exceptions better than how you do it in C, right? Now, before we actually get into what exactly is exception handling, let me just introduce the concept of exceptions and errors to you. So, just to have a quick view of what are the things that we're going to cover in this chapter. Exceptions, traditional error handling, try, catch, throw keywords. So these are the three new keywords which are there in C++, not available in C, right? And then you're going to see how we do a multiple catch and a single catch, and how we catch multiple exceptions, how we rethrow exceptions. Don't worry about all these right now, because once we understand what exceptions and errors are, these things are going to get more clear. Right then, let's start looking at what exactly is an exception and an error, and how traditional error handling was done. So when I meant by traditional error handling, we are talking about those programming languages which use the structured programming style. Now in C, we do not have an additional extension of handling errors or exceptions, right? So we have to write our own logic. We have to write the code along with the business logic in order to check for exceptions and errors. Now, since I'm using this word exceptions and errors, let's first talk about what exactly is an error and what exactly is an exception. Now, all of us know that a program can terminate abnormally, right? You've seen many times that you've compiled the code and you run the code, and while the code is running, you suddenly find that it crashes. Now, why did it crash? What happened that the entire program crashed? Sometimes your program will hang, sometimes you'll have to exit it. So why does that happen? Now that is where errors and exceptions come into the picture, right? Now, as a good programmer, what we must do is we must try and understand the reasons for why these programs can hang or they crash. So obviously it's not rocket science that the programs normally crash because of us, because the kind of code that we write can sometimes create a situation or a scenario which your runtime environment cannot handle, right? Some of the scenarios could be that you could run a loop infinitely. Now that is poor programming practice. So one of the programmer's task is to predict the scenarios and the situation under which the programs can crash. Also, when you go to an organization and when you're writing professional code, you're writing code for real-time applications, the quality of your program is judged by the way you actually predict and you take care of the scenarios which may lead a program to crash, right? So what exactly are exceptions now? So exceptions are those scenarios or situations or conditions in your program that can cause error. Now what exactly is error? Error is a condition where the program crashes. So error happens in runtime. So when the program is running, when the error comes into the picture or it encounters an error, the program shuts down or crashes. Now, can we handle the errors at that point of time? No, we can't. But can we handle an exception? Yes, we can. Now, when I talk about handling an exception, what I meant was try to first identify, can we try and identify the scenarios in which the errors may come? And if we know that the scenarios in which the errors may come and the programs may crash, can we take care of those scenarios? And if we can do that, we are basically handling exceptions, right? So there is a difference between exceptions and errors. Now there are certain some very simple conditions, right, which causes errors are like division by 0, right? Or for example, if there is no memory available for dynamic allocation, that means if you're trying to allocate something into the heap and there is no heap memory is not free, then you will cause an error. The other errors are basically when you're trying to access a file which doesn't exist, right? Or if the user enters a value which is invalid, that can also be an error. Now, when we talk about exceptions are not always conditions which can lead to the program crashing or failing, but sometimes we talk about business exceptions also. One of the examples of business exceptions are basically imagine if your system, for example, takes only 10 students. For example, you're creating a student information system and there should be only 10 students which the user enters, right? So for that scenario, suppose you enter more than 10, right? So if you have declared an array, there will be a problem. However, if you can take that situation, for example, if you create a system wherein if the student, if somebody enters the 11th data, the system tells you that, sorry, we have already exhausted the limit. Now, if you're doing that, we are also handling exceptions. So these kind of exceptions are business exceptions or exceptions in your business logic or your actual applications. So those exceptions which are system applications or system exceptions which can definitely cause the system to crash, but your business exceptions may not or may cause the system to crash. So we also have to look at the different kinds of exceptions and how we can handle them. And that is exactly what we are trying to do in this chapter, right? Now, before we move to the next part of this chapter, I would once again come back to a question of how C++ is different from C. In C, we do not have any extra extensions for error handling. However, C++ provides you an extra extension for handling exceptions. Now, this is one of the differences that you can state when you are asked in your placement interviews. Now, there are some keywords which are not available in C, but they are available in C++ to handle exceptions, and we're going to learn them soon, right? So there are some slides which I have given to you which are not important from the context of exception handling, but you can just go through those slides and see exactly what was the traditional approach for handling exceptions. For example, when exception handling was not there, or when you're doing exception, we're trying to handle exceptions in C, how do you do that? Right? So you have to write your own logic, you have to write some extra bit of code. So you have to mix the business logic with your error handling code. For example, when a function returns a value, right, you need to check and provide your extra additional logic to check whether any errors happened or whether the function executed properly or not. So setting of flags, setting of error variables, like setting the value of flags depending on whether error happened or not, and then revisiting those flags and checking them. So there are additional work required to handle errors and exceptions in a traditional approach. So you can just go through the slides, not very important from the perspective of how you handle errors in C++, but just to have an additional kind of knowledge of how it was done before, you can have a look at it. So what are the goals of exception handling? 4 things. The first thing is you need to detect the problem. You need to warn that the error has come. You need to accept the error message and then perform the accurate actions without troubling the user. So basically we are looking at a scenario wherein if an exception happens, we kind of tell the user that, look, there is some problem which has happened because you have entered this, and now I cannot go ahead with the process unless you do something about it, or unless you change the value. And the user can then change the value and the program can continue. Now this is basically the goals of an exception handling, right? So we will stop here for today, and in the next part of the video we will actually look and see how we can actually do the error handling in C++. Now the last line which is written here, that exception handling code is implemented in C++ by try, catch and throw keywords. So these are the 3 keywords available in C++ through which you can do error handling. So in the next part of the video we will see exactly how these keywords try, catch and throw are used. Till then, bye.